Now that we've learned a bit about JavaScript and how we can use JavaScript to communicate with our server, we're going to get into a new topic, which is caching. And caching allows us to take data and store it somewhere closer to where we would use it, so that we can access that more quickly. So one example of this is static files. If you think about static files, we don't, they're not dynamically created, so they should really stay the same. They shouldn't have to change from user to user. They shouldn't have to change from load to load. We should be able to save those somewhere. So one thing that your browser can do is it can cache files right in the browser, and that allows the browser to just load those from your local disk instead of having to go and make a request to your ISP or to your networks or to a data center. It doesn't have to travel all that distance in order to get to your machine. In fact, you can even use something like a content delivery network, which will allow us to replicate these files in different places so that they can be more readily accessed. Like one thing that you could have is a edge network where there are files that are saved and maybe even centralized across different applications so that they can be loaded very quickly instead of having to go all the way to an ISP or through the ISP through your networks to the data center where this is stored. So this can give us some advantages in the time it takes to load our applications. And we can also, we can always save those in different places automatically. Some of the architecture of the way that your browser works will do a lot of this automatically so that you can load these things faster. Now, caching in general does allow us quicker retrieval of resources. The further you get away from your processor, the slower things are. And if you think about this, if you know anything about processors, in your processor's registers, that's going to be very fast data access. There's pretty much nothing faster than accessing things from your processor's registers. But you can't put that much data there, so you use an L1 cache, which has a little bit more space. And then there's an L2 cache that has even more space than that and allows you to, to access things a little bit faster than your L3 cache, which has more space but is a little slower than the L2. And then you might go out to memory, which is going to have a lot more space, but also not be quite as fast as any of those processor caches. From memory, you might load data from disk, and that's going to be much, much bigger, but also a bit slower. Or you could even go to a remote server. So there's a lot of different options for where you can cache data, where you can pull that in, and where you can store that locally, either in your application's memory or some other mechanism so that you can access data even more quickly. There are a lot of different ways to do this in a web environment. You could cache data from the server in your JavaScript, so you could load some data into your JavaScript, keep that as objects, and display it on the page as you need to. You can use local storage to store data in the browser, and we're going to get to that in the end of this presentation. The browser can cache static resources on disk so that it doesn't have to call out to the network to get those every time. Content delivery networks can cache and replicate static resources so that those are just saved and available and a little bit easier to access. You can use Python code to cache data from the data store. You can pull data in and then store that as objects or store that as in arrays or other structures in your actual application. And you can even use a shared memory cache to share resources across VMs. This gets really interesting when we get into multiple server environments because what's in the memory on the server may not actually be everything that we need in the memory. So we might build up a very, very big object cache, but then not have that when we have to spin up a new server, or not have that for different users. So that can be a little costly, but sometimes that strategy works as well. Sometimes it's okay to have different caches on different machines, and we'll talk about that a little bit later. Now, there are several reasons you might want to not cache your resources. Sometimes you have a static resource that changes frequently. Sometimes during development you don't want to cache resources because you don't want to run into the problem of having something that is stuck, something that is just in your browser and you keep loading it no matter how many times you update the original file. So to avoid this, you can set HTTP headers. You want to set the cache control so that you can control that aspect of your application. And then there's a pragma and expires parameter or headers that will allow you to also control this caching. And you can do this in Python very easily. You can set those headers using the headers dictionary type object, and that will allow you to set those in Python. And you can also set these in your HTML code. So if you want to not cache an HTML file, this is an option. But you can always use that trick that we mentioned before where you change the name of the file, and that will force your browser to reload because your browser is going to keep track of these things based on the names of the files. So that's always a trick you can apply if you get stuck. Now, Caches can be stale. This basically means that the data in the cache is not up to date. So staleness is a problem in caches, especially if you're not building your application appropriately and you have a cache where there may be data in the database that is being updated without your cache knowing. So at that point, your cache, stale data in your cache might cause problems, because if you go to load data from the cache but you don't realize that it's been updated in the data or in your data storage system, you might be pulling in data that is not up to date or maybe even incorrect based on timing. So you want to avoid a stale cache, and one of the ways that you can do this is through different caching mechanisms. So one of them is lazy loading. Basically, in lazy loading, you check the cache to see if the data is there, and if it's not, you go to the persistent store and maybe you cache it at that point. So there are smart ways to do that, where you have basically a cache object that handles the retrieval of that data and the retrieval of the data if it's in the cache. So that way you can kind of serve both purposes. But basically, in this approach, you're assuming that you're going to access data that you've already accessed. So keeping it in some type of cache, even if it's just a plain object, that will allow you to get some of that data more quickly. Another option is a write-through cache, where anytime you update your data, you update a caching layer, whether that's an object or something else, and that caching layer then writes through to the persistent store. This allows you to very easily look data up again, because when you write through, you update that cache, that data now is in memory and it's up to date, but it also updates in the persistent store, so if you need to reload, it's available there as well. Then the other option is a write-back cache, where you write to the cache, but it sort of queues up the writes. So what happens here is that it might take a moment before the persistent store is updated. This is good sometimes, because it allows you to be a little bit quicker with when you're writing to the cache. You get a response faster, but it's also a little bit dangerous in certain applications, because those writes might not happen until much later in your application. So that can cause a few issues. But it depends on the purpose of your application, and what data might be lost in this write back approach. So one way to do this is to store information right in the browser. And that's something we can do with something called local storage. So local storage is a form of caching and allows you to store information in the browser. So there is a local storage object that is built into your, whenever you're using JavaScript in the browser, you can use this local object, and it works just like a key value store. So we can set an item based on a key, and that value can be pretty much any object you like. You can also get item, and that will retrieve that particular object by a key. There's also a session storage, which will operate for the user's session, so that doesn't stay forever. But local storage can actually persist from visit to visit, so that's actually really nice, because then you can store some amount of data on the user's browser without having to always be calling back to the server for it. So this is nice if a user just reading something on your page. You could, in the background, be calling out and retrieving a bunch of information, store that in local storage, and then retrieve it from local storage in JavaScript as you need it. So this gives you an opportunity to cache some data in the user's browser, allows you to very quickly call that back when you need it. So using different caching strategies, you can make your data access a little bit faster. You can make loading your JavaScript a little bit faster by going directly to a data structure you have in memory, or using local storage so that you can access that very quickly. So this can help, this is a good strategy to know, and it's a good way to approach some different data problems in your applications. Hopefully it'll be helpful as you explore your needs for what you're building. Thank you for watching.